guys. Welcome back from your Thanksgiving holiday. I hope you had a lot of fun and ate lots of turkey. Of course, we've already said hello, so I should just get on with the lesson. Okay, so we're going to learn about ratios. You've been dying to learn about ratios, and here we are. What are ratios? Well, they're really comparing two quantities. I suppose you could compare more than two quantities, but generally speaking, what you most often see is the comparison of the size of two quantities. So let's get some examples of that. Oh, I've got this out of order. Hold on. Don't look at that. Don't do that. Okay, that will happen later. All right. So examples of two quantities. Well, let's say, if we look at the ratio between students and teachers, we call it the student-teacher ratio. In our class, it's 28 to 1. So so when I say 28 to 1, then that's definitely student to teacher ratio. If I wrote 1 to 28, that would be teacher to student ratio. So it matters which you put first. You have to say it correctly. Let's see. There are a couple of ways that you can write that. I'm going to get rid of this one. Okay, so we can just focus on one kind. So 28 students to 1 teacher. You can also do this, 28 to 1. And then there's one other way too that you can do this when you write ratios. You can also write it as a fraction. And so this particular one would be that. Just kind of awkward looking, I know, but you don't often see that. It does come up, it comes up in other situations. Oh, I need to clean that eraser. Here's some other examples. What is the ratio of girls to boys in our class? So now I'm looking at girls to boys. Are you trying to count all the way around the classroom? Well, I don't know. You could do that, but it might take a while. I already have the numbers for you. Sorry, boys, it's 16 to 12. So that means that there's 16 girls to 12 boys. This is an interesting one because we could actually say that the ratio in our class of girls to boys is 4 to 3. Do you see where I got that? It's the same. This is where we get into equivalent fractions. So if we wrote this as a fraction, 16/12, it's equal to 4/3. So that's where ratios and fractions come together. That's why we're doing ratios after we've learned fractions. Should we do one more? I think you get it, but we'll do one more. What's the ratio of 5th graders to 6th graders? Do you know? I bet, well, this might help. Well, I know that there are 15 6th graders in our class. So if there are 15 6th graders in our class and we have 28 students, then the ratio of 5th graders to 6th graders is 13 to 15. Okay, get the idea? Have we had enough of that? I'm going to give you a little bit of practice. Now here's where we see the slide. There's only 6 problems that you're going to do. The guided practice problems on page 119 to 120. So go ahead and press pause and come back when you're finished. And do this on a new piece of paper with your name and the date and the assignment, page 119. We're going to continue with this, so be sure and write guided practice problems first. And then go ahead and get started. It won't take you very long. So, are we back? You finished? I want to ask you about number 6. What did you decide for number 6? Can these two quantities be expressed as a ratio? Can you make a ratio between 3 ounces and 30 inches? So if you think about 30 ounces, we measure ounces in terms of volume. So you might get a drink that has 16 ounces. So this is volume, the amount inside a container. And this is 30 inches, right? Length. So can you make a ratio? No, you can't. That was the only one that you couldn't make a ratio with. So you can't mix units that aren't at least measuring the same kind of thing. So now we're going to continue And so the next thing that I want to show you is how ratios fit into bar modeling. We're going to do two different types of bar models. We're going to use a scenario, and I'll just tell you, you can follow along in the book. It's on page 121. So let's see. So we're going to pretend there's this party, and at this party, I'm going to draw the bar representing all the people who are attending this party. At this party, there are 55 adults. So we'll say 55. And there are some kids. They get to come too. Yay. There are, what's your book say? 32. So there are 32 kids at this party. So this is an example of a bar model that shows a ratio of adults to kids, right? There's a ratio of adults to kids. We could write it like this, kids to adults. The placement in the bar doesn't make a difference. It just matters how you read it and how you say it. So if I said the ratio of kids to adults, I would say 32 to 55. Okay, but this is a part bar model because we're looking at two parts in the bar model. So what if we wanted to make another kind of ratio and we looked at the part whole type of bar model? So now I want to make a ratio that includes a comparison of a quantity to the whole. So a part of the quantity to the whole. So basically, how many people are at this party? We'd have to add them up, 55 plus 32. Do you have it in your head? You should. So 87. So there's, oh, I can't write on the side. Okay, no laughing, 87. All right. So there's 87 people at this party. If I wanted to make a ratio of kids to everyone at the party, well, what would that be? Did you think 32 to 87? So the ratio of kids to all the people who came to the party is 32 to 87. It's really that easy. It's not complicated. So I'm going to give you some practice, a few problems. And so I'd like you to get started on the guided practice problems, so continue on that same beautifully organized paper that you started earlier. Page 121 through 122, you're going to do these guided practice problems, numbers 10 through 12. And when you're finished with that, take out a new piece of paper and you'll start the assignment. This is 3.1, isn't it? Are we in chapter 3? No, we just did chapter 3, sorry. Chapter 4. 4.1, page 125 through 126. You're going to do the first 10 problems. But I really want to see you draw a model for number 9. The book doesn't say that you need to do that, but I said you need to do that. So please draw a model, much like this. Look at that in your book if you need some examples. When you do these problems, you'll see more examples. So, okay, thanks you guys. I'll be wandering around the classroom if you need help. So just ask.